Okay. So then I would like to ask Yoshua to start the first presentation. So as all of you know, so Professor Bengio was awarded the Turing Award for his contribution for the deep learning. And he's also an author of the definitive textbook on deep learning. So he's also serving as an AI chair for the CIFAR in Canada. So, and also he's quite actively involved in the topic of how to control the development of AI. So then, Yoshua, please start your presentation.
Sure. Let me know if you see my slides.
Yes, we can see a slide.
Excellent. Okay. So I want to tell you about the worst thing that could happen if we're not careful, catastrophic AI risks, and how to mitigate that. Mostly talking about governance, but also a little bit about, I think, the need for scientific research to learn how to control AI systems when they become smarter than us. Because right now, we don't know. And we are racing ahead with all the companies trying to build AGI. Okay, so first, there's a lot of evidence that we are going towards AGI. Of course, we can only look at the past, but if we continue those trends, I'll show you some graphs. There's a good chance we will get there. And if we do, I think it's important to think about the consequences, the promises and perils of reaching human level AI, in other words, AGI. Here are some benchmarks that were put together of machine learning methods over the last 2 decades, making progress with respect to human level performance, which is the black line at 0. And that includes even more advanced tasks like mathematical tasks and reasoning tasks more recently. So you can see that on mini metrics, these systems, new versions of these systems, of course, are getting better, and in many cases getting better than humans. But we are not there yet. And there's a lot of uncertainty about the timeline of when we reach AGI. So I think from the point of view of public policy and governance, we need to plan for the cases where it may happen very soon. Maybe the soonest people think could be a couple of years or 3 years. And of course, it could be 5, could be 10, could be decades. In my opinion, it maybe is like 3 to 30 years, you know, is plausible. As I said at the beginning, the most important bit of information you should take out of this talk is that we don't know, like scientists don't know how to build AI with assurances that it will not harm humans. And yet we continue like racing forward. And in fact, even the current systems, there's a lot that we don't understand. Of course, we understand their learning procedures, but once they've learned, you know, it's like children or people. We don't really know how they come to their conclusions. In fact, we know even less because they have a hard time explaining their conclusions. Also, there's evidence that once you give them goals, like you train them with reinforcement learning, they can naturally use deception in order to achieve their goals. And there's been a lot of research in the last few years to try to make them act according to our intentions. It started with reinforcement learning with human feedback, RLHF, more recently things like Constitution AI, all kinds of pre-processing and post-processing of these chatbots. Unfortunately, all these safety protections currently are easily bypassed, especially if you have access to the open source and shared weights. There's another approach that has been taken to try to limit bad things happening, which is to evaluate their capabilities before they are deployed. Do they have, for example, the ability to help people build bombs? Or do they have the ability to do dangerous cyber hacking? Do they have the ability to persuade humans to change their political opinion? So we can test these things. And unfortunately, the tests we have, what called evals or evaluations, they are spot checks. They try different circumstances, different questions we can ask the AI. But if they don't find anything, it doesn't mean that they don't have the capability. It just means that we didn't find it. There's no handle on the false negatives. Okay, so the other thing to think about is, okay, we humans are designing these algorithms, and we're approaching AGI, human level. But what happens as we reach AGI? Well, at that point, we may be able to actually design AI systems that are very good at being like an AI researcher or an AI engineer. And so they could design the next generation of AI systems. In fact, when we train a single model like GPT-4, once it's deployed, it can represent a workforce of tens of thousands or even millions of AI researchers, because you can run all of these instances in parallel on many GPUs. And so imagine OpenAI goes from a few hundred strong researchers to a few 100,000. That's going to create an acceleration of advances in AI almost certainly. And well, how is this going to be used? It could be used to help design safer AI. It could also be used to make the AI more capable and potentially more dangerous. So it's really important that we figure out how to control entities that could be much smarter than us, but we haven't figured it out yet. And the reason we continue racing forward is because there's a huge magnet of at least quadrillions of profits. And this means companies want to compete with each other very strongly, very aggressively, and they don't want anything to slow them down. So there's already now, in the last year, setting up a very powerful lobbies to prevent legislation or to make legislation basically not very effective. In addition, regulation is very slow to put in place. Legislation can take years. Creating a new regulator in this area that requires strong technical skills is going to take a lot of time. The states don't have that expertise right now. It's all in the companies, in the private sector. And for companies, the risks are economic externalities. In other words, it's a cost that's shared by everyone. And so they have an incentive to just somewhat ignore those risks. But hopefully governments will be able to legislate to reduce the dangers of that competition. There's another kind of competition, which maybe is even more dangerous, which hasn't really started too much, but it will probably happen, which is the competition between countries. Not just economic competition, but also military competition. And it's not clear that, for example, the leading AI countries like the US and China will be willing to trade sovereignty over their AI systems to reduce risks that have never happened, or even to distribute the benefits of AI to improve global justice and distribution of power. There are also other reasons why the incentive structure is not very good. The leaders of these companies want to feel good about their work. Like everyone, they have an ego. They might think that they know better, hubris, how to deal with these problems. And any person working in these companies, or even like AI researchers in academia, they might have psychological biases, so that they would rather look on the positive side of AI rather than the risks. So because of all these factors, it's difficult for the people involved in developing AI to be honest about risk. And yeah, it seems to me that humanity is sleepwalking towards a potential catastrophe that we don't understand. But of course, we don't see that catastrophe. It's hiding behind a fog, and that's what makes it difficult for people to realize that there is a very serious risk. So where is that risk coming from? Well, intelligence gives power. Knowledge gives power. And AI is knowledge plus the ability to apply that knowledge, to make inferences, to reason, to plan, to achieve goals and answer questions. Now, of course, we have systems that are, for now, very good at knowledge and not so good at planning, or very good at planning and not so good at knowledge. but it's likely this will change as, you know, huge amounts of money are invested in AI. And the question is, you know, when an AI can achieve goals better than humans, who decides on those goals? Who decides on the queries that we ask these AIs? If the goals are beneficial, then it could be extremely good for humanity. If they, you know, allow people to grab power, it could be very bad. And if the AI is very powerful, that could be huge power. Yeah, so when thinking about what needs to happen in order to avoid these catastrophes, there are two fundamental things that we need to get right. One is scientific. How do we control future AI systems? The alignment or the control problem. There are two variants of the similar problem. And the other is political, also called the coordination challenge. How do we make sure that even if we had safe and ethical protocols, they would be followed in all the countries, in all the corporations? And, you know, we need also at the political level to think about what happens if the regulation and the treaties at some point fail and some kind of rogue AI emerges. How do we prepare for that? How do we make sure that no single person, no single corporation, no single government can take advantage of AGI to grab a lot more power? So yeah, these are really hard problems. And compounded with that is the fact that there's a lot of uncertainty about when we will reach AGI. Maybe never, maybe in a few years. And we need to be ready. We need to be prepared. It's like pandemic preparedness. We need AGI preparedness, but it's anytime preparedness. Like we don't know when it's going to happen. So we need to start projects now to do the best we could in 2 years, in 3 years, in 5 years, in 10 years, in 20 years. So the more ambitious projects take more time and they might give us a better handle on the risks. But we also need to do short-term projects. You know, it happens in just a few years. Already these evals are useful, even though they're imperfect. We need to have them not optional. They have to be mandatory for companies, and we need to improve them. We need to improve the technology for aligning. I mean, there's already a lot of work, as I said, but clearly it's not satisfying because there are lots of failure modes. We need to understand those failure modes. And we need to work on the political side as well. We need governments to invest massively in AI safety to understand those risks and to research those technical solutions to control AI systems. And we need to start the discussions on international treaties. We need to start the discussions on investing in technology for verification, because there's not going to be any international agreement between adversaries like China and the US if there is no way to verify that the other guy is complying. We need to make sure that the corporations working on these systems have the right kind of governance, multi-stakeholder and multilateral, because the impact of catastrophes, of misuse and loss of control, they are likely going to be worldwide. And as I said, like we need to really invest in research to help design systems that will be safe by design, that will give us guarantees as much as is possible that the systems will not, harm humans. They will not turn against us. So in my research, that's what I'm focusing on. And it could be useful, even if we only have slight improvements in terms of safety, to have the best we can the day when these evaluations report that something dangerous is happening. They detect that we have a dangerous capability, like copying yourself on the internet, as Kenji Doya was saying. Defeating and deceiving humans. So there are different kind of evals. The ones that based on handcrafted questions, that's a start. There are like red teaming, where the people who answer questions can interact and look for problems in the AI. And then there's automated red teaming, which is, I think, currently our best bet for evals, where we use machine learning and optimization to elicit bad behavior, to try to make the AI reveal that it has, something bad in terms of capabilities or intentions. We need better responsible scaling policies like, the one that Anthropic proposed. Not only something vague and qualitative, but that these policies are enforced by regulators. So these policies basically say, when we reach a certain level of capability, we stop until we find a solution. Right. But right now, what is that level? There's no numerical threshold, no vague specification, and some companies can do it, some decide not to do it. The day when that happens, when we reach those red flags, those red lines, what's going to happen? Because of the competition between companies or because of the competition between countries, it's very plausible that it will be decided to continue moving forward, especially if there's a big cost to putting safe systems in place. So it would be better to have found safe by design methodologies by the time we reach that point, so that the choice will be easier to make towards safety. Now, let me say a few more words about what can go wrong. As I said, AI is really about achieving goals. And so there's, I said, who decides on those goals? But there's a special kind of goal I want to talk about. It's the goal of self-preservation. Every living thing has a self-preservation goal. I mean, implicit, of course, in general. If an AI had a self-preservation goal, it would be terrible. I mean, it would resist being turned off. It would actually make sure that we can never turn it off. That means it would try to control us. For example, by persuasion, political control with, installing dictatorships. Or even worse, if it can control robots, and robotics has advanced either because of human researchers or because of AI researchers. Then if AIs have sufficient control over robots, then they don't need humans. And so the safest thing for the AI would be to get rid of humanity as a whole. There's never been any threat in our history that could conceivably, eliminate all of humanity. I mean, if an AI that is smarter than us actually wants to get rid of us, we are in big trouble. So how could an AI get to have such a self-preservation goal? Well, the simplest route is that humans will give it. Will give that gift of self-preservation because, for all kinds of reasons, ideological reasons, or even religious reasons or whatever. There's also a lot of computer science research on how self-preservation emerges as a side effect of our design and instructions, especially when we train them with reinforcement learning. Okay, a few more words about governance. In the last 7 months, I've been chairing the International Scientific Report on the Safety of Advanced AI that came out of the UK AI Safety Summit in Bletchley last November. So it's a kind of IPCC-like organization, except it's not in the UN, but it's what came out of that forum last November. So the countries agreed to create a report that would synthesize the state of the science, not provide any scientific, not any political recommendation, but a synthesis of the evidence and the discussions and the arguments made by scientists. So there are 30 countries, the EU and the UN, 70 experts, and we already provided an interim report last month at the Seoul AI Forum. The final report will be delivered in Paris next February. So a few conclusions, recommendations or thoughts that I have following from all that work. So the report talks about uncertainty in the timeline, that dangerous AI could be soon. Of course, it could be much more. And my personal conclusion is that we're not prepared in case it comes quickly, and we're not really good at dealing with exponential changes and if things accelerate. So we need to prepare for those risks now. We need international agreements on risk thresholds and early warning shots. We need research to measure these capabilities I was talking about and their consequences. We need response plans if the risk thresholds are crossed. We need to make sure we actually take seriously the precautionary principle here, which is not what is happening right now. And as I said, we need anytime preparedness. We need to have different plans for different timelines. Another message of the report is that the capability evaluations that currently exist for AI safety are useful, but they provide no handle on false negatives. If they don't report anything, well, there might still be a problem. And there's no method that guarantees safety in how to train these AI. As I said, and I'm going to repeat, we need to invest massively in research on safe by design AI systems with quantitative guarantees. Finally, the report talks about the competition between developers, mostly thinking about the race to the bottom for safety among corporations. But what the report didn't talk about very much is the competition between countries. And there, I think it's worse, because there's no Uber world government that can tell the US or China or any other country that they shouldn't act in a particular way. I mean, the UN has no teeth, right? And so what can we do? Well, we need to facilitate those treaties that those countries could have in the future to develop transparency of what is happening and hardware-enabled governance mechanisms to enforce that, to verify compliance with treaties. All right. So besides that, as I said, I've started a big research project on developing safe by design AI systems. And if you're interested, don't hesitate to reach out to me. And you'll see some information on it in my blog.
Okay, thank you very much, Dr. Bengio, for your presentation. So for this session, I'm also asking organizer, Professor Joito, to coordinate discussions. So yeah, if you have any questions or comments,
we have about 5 minutes. Go ahead, Vanessa.
Hello, thank you very much for this very inspiring talk. I'm Vanessa Newark. I'm a philosopher from France. So sorry for my French accent. I hope you can get it. I have a question about the focus on risk and on safety by design. I'm a philosopher, I'm an ethicist, and I would like to point out the fact that sometimes what is safe is not ethical. Sometimes we decide to take some risk because we believe that this risk may lead us to, get something. So of course, I'm very much aligned with what you say. So that's why I'm not trying to ask you some questions about the idea that we now urgently need to do something. What I'm a bit puzzled about is what can we lose if we focus only on safety by design? Because it hadn't been shown, for instance, with nanotechnologies where safety by design was really very much used. Everything cannot be foolproofed. So at some point, you don't know, and you said it yourself, what will happen. So there are limits, obviously, to safety by design, some like technical limits, but also some more conceptual limits. So that's on the conceptual limits I would like to
Okay, so I have a simple answer to this. The kind of approach that I'm following is probabilistic. So what you get is a probability of harm if you follow some of the recommendations of the AI, if you follow the action, if the action proposed by the AI is accepted. And there's going to be a threshold of what is the acceptable risk. It's like when people build a nuclear plant or a plane. Of course, they cannot guarantee 100% risk. You can have mathematical proof that the plane is not going to fall. But you can make a model and you can calculate risks, and then it becomes a social decision. Where do we put the threshold? It's not for me, a scientist, to decide that. There's going to be, as you say, advantages and disadvantages. And by the way, it's not black and white, because we can have AI that's specialized for different tasks, and we can choose to do more of the things that are less risky and less of the things that are more risky. So, but these are governance choices. But right now we don't have the technical tools for even estimating those risks, and that's what I'm trying to provide.
Thank you. And we have about 3 minutes. If somebody has another question or a comment? And you're in the audience, please come up to this mic. Thank you. You might have to turn it on.
Hello? Yeah, wonderful.
Yes.
Thank you so much for the talk. I'm Wolfgang Schulz from the Humboldt Institute for Internet and Society in Berlin. I have two quick questions. One is, we are very much focusing in the debate on the development of models and things like that, but not so much on the application side. What is your view on that? Do we focus on the right element? Are some of the safety elements things that are more application orientated? And the second one is we just enacted in the EU the AI Act. My question would be, do you see some elements there that go into the right direction that can be helpful for this debate on a global scale, or do you see the concept basically not helpful or flawed? Thanks very much.
Well, I think we should develop a lot of AI applications. I'm not against the deployment of AI. I think we need to be careful, but it doesn't mean we don't do it. There are human rights issues. For example, the EU AI Act in its initial draft was focusing on these questions, and we do need to be mindful of these things, absolutely. Personally, I'm focusing my time on the greatest risks, so the major misuse and loss of control. And the EU AI Act has been modified to try to take these into account in the latest version. It can still be watered down by lobbies. They're pushing very, very hard to water down the actual effectiveness of the act. So we'll see how it turns out. I think the EU AI Act can play a very positive role in the world. My feeling is that it's maybe we have to be careful that it doesn't become too rigid. The technology is moving very fast. The applications, as you said, there's going to be a lot that we didn't anticipate. The misuse also might change that we didn't think about. The science moves. And so the regulator needs to be very agile. And if it has too, strongly defined rules and definitions, it might be difficult. The Canadian proposal for a law actually is, I think, moving in an interesting direction of what's called principle-based legislation, where the legislator only states sort of high-level goals for the regulator, and the regulator is then allowed to adapt based on the changes in the technology, a little bit like the FAA and the FDA in the United States. I think we need that sort of thing for AI, obviously, because we can't wait another 3 or 5 years to change legislation like this.
Thank you very much. Thank you, Yoshua. We're going to now move on to the video from Stuart Russell. Thank you very much.